Welcome, everyone, to today's Explainer. We're looking at something today that feels like an absolutely massive shift in artificial intelligence. For a while now, we've lived in this world where AI simply answers our questions, right? We ask, it tells. But we're stepping into a completely new reality where AI proactively takes over the keyboard to execute complex tasks entirely on our behalf. It's a transition we're calling the agentic leap. And honestly, exploring how it works is going to completely change how we think about computing from here on out. Okay, let's dive into this. To really get the immediate shock value of what AI labs are building right now, just consider how the cybersecurity firm Plurilock puts it. That's not a chatbot, that's an operator with credentials. I mean, wow. That perfectly captures the moment we're in. We aren't talking about a helpful autocomplete tool anymore. We're talking about giving AI systems autonomous control to click, type, and navigate multiple desktop applications exactly like a human would. The AI is no longer just a brain in a box. It now has hands. So here's our roadmap for today. Number 1, the agentic paradigm shift. Number 2, inside the command center. Number 3, the science of planning. Number 4, everyday impact for everyone. And finally, number 5, the new attack surface. Part 1, the agentic paradigm shift. Think about reactive autocomplete for a second. The AI we're used to. It just sits there completely dormant, waiting for a human prompt so it can suggest some text or a snippet of code. It relies entirely on your momentum. But autonomous orchestration, that's a totally different mental model. Instead of waiting for you, an agent operates in parallel. It navigates your operating system's interface, it moves between apps, and it executes these long-term tasks over hours. It's literally like having a team of junior developers or assistants working continuously in the background while you focus on higher-level strategy. The dynamic shifts from you simply using a tool to you managing a digital colleague. To really grasp how far this autonomous capability has come, just consider OpenAI's Codex. It has a locked use setting specifically for Mac. So what this means is that from your smartphone, you can trigger Codex to securely use desktop apps on your computer, even when the screen is completely off and locked. Your AI is sitting right there at your desk, moving the cursor, and completing tasks while you might be out grabbing a coffee or commuting on the train. It fundamentally changes our physical relationship with our hardware. It completely breaks the tether between human presence and computer productivity. Part 2. Inside the command center. When you trigger a tool like the Codex/goal command, the AI enters this incredibly powerful full auto loop. First, it independently plans a sequence of actions. Second, it executes those shell commands or text edits. Third, and this is the absolute crucial part that makes it truly autonomous, it checks its own work. It might run a test or read an error log. Finally, if something fails, it enters a self-correction phase where it learns from the mistake and tries a brand new approach. This whole loop can run entirely unsupervised. It's not just following a rigid script, it's actively problem-solving in real time, handling those inevitable roadblocks that pop up in any complex workflow. Let's look at how this actually translates to real-world productivity. Take this mid-sized fintech team, for example. Their senior engineers were constantly drowning in context switching, just losing hours to minor fixes. So they decided to orchestrate 3 AI agents simultaneously. They had Agent A building the user interface components. Meanwhile, Agent B was working in the background, triaging legacy authentication bugs. And Agent C was writing all the automated API tests. The result? A massive 40% reduction in their cycle time. Human developers were totally freed from the repetitive, tedious implementation work and could finally just focus on the big picture, architectural problem solving. It's a real game changer. Part 3. The science of planning. Now, what's really interesting about this is how an AI interacts with a standard smartphone screen to achieve a goal, like checking the news or opening a specific app. It has to visually parse an incredibly chaotic environment. It has to recognize icons, understand the graphical user interface, and decide exactly where to tap or swipe. And because the screen dynamically changes with every single interaction, there's no static code to rely on. It's not a neat little database. The AI's plan has to be flawless in a constantly shifting visual landscape, which is a massive, massive leap from just parsing text in a chat window. Researchers actually found that older methods were completely failing at this dynamic navigation. The standard React method tries to feed the AI the entire history of the dialogue and past actions. But the context window gets way too long, and if the AI makes a mistake early on, it tends to get stuck in this super frustrating loop, just repeating the same incorrect action over and over. The breakthrough here is the DPOT method, or dynamic planning of thoughts. Instead of rigidly following a broken path and getting confused by its own history, Depot dynamically adjusts its plans on the fly based on the immediate visual feedback of the new screen. It evaluates its current state, tosses out what isn't working, and charts a new course. When researchers utilized this Depot framework for graphical user interface tasks rather than relying on a standard GPT-4v baseline, they discovered a 12.7% jump in accuracy. Now, in the world of AI automation, a jump like that is absolutely massive. It's the difference between an AI that's just a frustrating, glitchy novelty and an AI that is a dependable daily tool. By allowing the system to continuously refine its plan and learn from its immediate visual environment, it successfully mitigates hallucinations and navigates totally unfamiliar applications with genuine reliability. Part 4. Everyday impact for everyone. So what does all this actually mean for the common person, not just software developers? Consider a reader in London named Loic. He had torn the ACLs in both his knees but was relentlessly preparing for a brutal 5-hour multi-sport adventure race. He didn't just ask ChatGPT for a generic workout plan. He used voice capture after every single running session to tell the AI exactly how his body felt, noting any pain or fatigue. The AI agent then dynamically adjusted his upcoming program to maximize his training time while minimizing the risk of re-injury. As he puts it, he built a personalized coach in his pocket. It's just a perfect example of AI adapting to the messy reality of everyday human life. Because these new tools require almost zero friction onboarding, anyone can use them. You don't need a computer science degree. For instance, you can use tools like Composio alongside an agent to autonomously connect right to your company's Google Analytics. Without writing a single line of code, you can just tell the AI in plain English to pull the top 3 traffic trends from the last 90 days, build an executive markdown report, and schedule it to automatically run and email you every Monday morning. We are talking about total workflow optimization and habit building that is finally accessible to the common person. It really levels the playing field for productivity. Part 5. The new attack surface. Of course, it's not all sunshine and roses. Organizations simply cannot let these agents run completely wild. Giving autonomous systems credentials introduces incredibly urgent security implications, so there are mandatory governance rules we absolutely have to consider. First up, review before merge. Despite all the automation, a human must still verify the work an agent does to ensure no security vulnerabilities are getting introduced. Second is sandboxing, which means restricting the AI's file system and API access. This is notoriously tricky because agents need broad access to actually be useful. But if you don't restrict them, well, they can accidentally or maliciously modify production infrastructure. Finally, you need strict audit trails. If a mistake happens, you need a verifiable log tracking exactly which agent produced which action and based on what human prompt. So, as this attack surface expands right alongside our productivity, it leaves us with one incredibly urgent, final question. Your computer now has an autonomous operator. Are you ready? Thank you so much for joining me for this explainer, and as always, keep learning.